to attack network protocols, you need to understand the basics of computer networking. The more you understand how common networks are built and functions, the easier it will be to apply that knowledge to capturing, analyzing, and exploiting new protocols. Throughout this course, I will introduce basic network concepts you will encounter every day when you are analyzing network protocols. I will also lay the groundwork for a way to think about network protocols, make it easier to find previously unknown security issues during your analysis. Network architecture and protocols. And let me write here something. Actually, this is the network, and we have, for example, workstation. Actually, it does computer. So this is the workstation, for example, and here so let's add one laptop again here, for example, and oops, and workstation here. And for example, let's add server again. This is the server, and let's add another server here. So these are the networks. So we will introduce more deeply about them. So this figure shows actually 5 nodes connected with a common network. So each node might have a different operating system or hardware, but as long as each node follows a set of rules or network protocol, actually, oops, let's write down here. Okay, network protocol here. So, but as long as each node follows a set of rules or network protocol, it can communicate with the other nodes on the network. To communicate correctly, all nodes on network must understand the same network protocol. A network protocol serves many functions, including one or more. For example, let's write it down here. Text here. So, oops. So, network protocol functions here. Network protocol functions. So what network, as I already told you, that network protocol serves many functions, including for example, maintaining session state. So what maintain session state means, these protocols typically implement mechanisms to create new connections and terminate existing connections. Create new connections and terminate. Actually, can I do like that? Yes. And terminate connections here. So these are the functions of network protocols, and this also identify nodes through the addressing. Oops. By nodes. So what identifying nodes through the addressing means, let me Okay, so data must be actually this addressing. So data must be addressed. So and transmitted to correct node on a network. So some protocols implement an addressing mechanism to identify specific nodes or groups. Actually, some protocols, actually not some some protocols implement an addressing mechanism. An addressing mechanism to identify specific nodes or groups of nodes or groups of nodes. And here this network protocol serves many functions. As you know, one of them is controlling flow, controlling flow. So the amount of data transferred across a network is limited. Protocols can implement ways of managing data flow to increase throughput and reduce latency. And we have also guaranteeing the order of transmitted data. The order of transmitted data. So many networks do not guarantee that the order in which the data is sent will match the order in which it's received. A protocol can reorder the data to ensure it's delivered in the correct order. And we also have detecting and correcting errors. So many networks are not 100% reliable. Data can be corrupted. It's important to detect corruption and ideally correct it. And we also have lastly formatting and encoding data. So data isn't always in a format suitable for transmitting on a network. So a protocol can specify ways of encoding data, such as encoding English text into binary files. So we have also Internet Protocol suites here. Let's come here. So the TCP/IP is the de facto protocol that modern networks use. TCP/IP. So this protocol, actually, although you can think of TCP/IP as a single protocol, it's actually a combination of two protocols. So what TCP/IP means here, text here, TCP/IP is TCP/IP is a combination of two protocols. These are the actual. Can you see my screen? Yes, these are the transmission control protocol plus internet protocol. So these two protocols form part of the Internet Protocol Suite, IPS. So a conceptual model of how network protocols send network traffic over the internet that breaks down network communication into 4 layers, as shown in this illustration. So as you can see, Internet Protocol Suite, application layer, transport layer, internet layer, link layer, and these are what these layers use, what protocols these layers use, and this is the link layer, is the physical layer. So these are the 4 layers from a protocol stack. So this link layer, actually link layer, this is the layer 1, layer 2, layer 3, and layer 4. Let's start with link layer, layer 1. So this layer is the lowest level, and this describes the physical mechanisms used to transfer information between nodes on a local network. Well-known examples include Ethernet. Here, can I show you? So this is the Ethernet port, for example, or point-to-point protocol. So these are the physical layer, and top of them, this is the layer number 2. So this is the internet layer. So this layer provides the mechanisms for addressing network nodes. Unlike in layer 1, the nodes don't have to be located on the local network. This level contains the IPv4, IPv6 on modern networks. The actual protocol used called either be IP version 4 or IP version 6. And then let's talk about our third layer, transport layer. This layer is responsible for connection between clients and servers, so sometimes ensuring the correct order of packages and providing service multiplexing. Service multiplexing allows a single node to support multiple different services by assigning a different number for each service. So this number is called a port. TCP, the user datagram protocol, operate on this layer. TCP and UDP operate in this transport layer. And lastly, we have application layer here. So this layer contains network protocols such as hypertext transfer protocol, HTTP, which transfers web page contents. We have the simple mail transfer protocol, for which transferring email, and domain name system protocol, which converts a name to a node on the network. Throughout this course, we will focus primarily on this layer, actually, but we will focus on all of these layers, so this is the most important layer for us. Each layer interacts only with the layer above and below, but there is a must be external interaction within the stack. So like that. One here. And here. So now let's create a new figure to for better understanding. Here, this is the one box here, and this is the mail application. This will be our mail application here. Mail application. This is the mail application, and this is the human here. Let's just an user here, for example. This will be our user. So let's add some box here as well. So this will be a user interface, which is HTML rendering, and we will content parsers here, content parsers like text, HTML, GPG, content parsers. What this will is text, for example, HTML, GPG, and we'll top of below them is we will have network communication, network com. So what this will is SMTP, for example, POP3, and IMAP. So this is the email application. So SMTP, POP3, and IMAP is the mail protocols. And this will be network here, and server here, server. This network will go to directly this server, and user interface will directly go to our human. So typically applications contains these components. First is network communication. So this component communicates over the network and processes incoming and outgoing data. For a mail application, the network communication is most likely a standard protocol such as SMTP, POP3, and IMAP. And we have here content parsers as well. So data transferred over a network usually contains content that must be extracted and processed. Content might include textual data such as the body of an email, or it might be contain pictures or videos. And we have user interface for user. So the user interface allows the user to view received emails and to create new emails for transmission. In a mail application, the user interface might display emails using HTML or PHP in a web browser. Note that the user interacting with the user interface doesn't have to be a human being. It could be another application that automates the sending and receiving of emails through a command line tool. And we have here data encapsulation, which we will discuss this in next lecture.